Greetings and welcome to the 2023 walkthrough for the SASMO Grade 9 paper, and this will be targeted at the secondary 3 students in Singapore. SASMO stands for the Singapore and Asian Schools Math Olympiad. There are 25 questions in total that spans over 1.5 hours. The first 15 questions are multiple choice questions. You get 2 marks for each correct answer, but do note that there is negative marking, so you'll lose 1 mark for each wrong answer, but you get no marks if you leave it blank. The next 10 questions are open-ended. You get 4 marks for each correct answer, but there are no penalties for wrong answers. Do check out their website in the info section for more details like the percentile breakdown for the awards or the attractive $100 voucher for a perfect score. Question number 1. Calculate this alternating sum. So it's 2,952 plus 2,950 minus 2,948 minus 2,946, and this continues all the way to minus 4 minus 2. Pause the video here and give this question a good try. Notice that this pattern comes in groups of 4 terms. Each term decreases by 2 and the sign alternates plus plus minus minus. If you evaluate the first group of the 4 terms, it gives a total value of 8. In fact, you can check that every group will give a constant value of 8. So we just need to know how many of these groups are there. Well, notice that the first term in each group is a multiple of 8. So to find out the total number of groups, we'll just take 2,952 and divide it by 8. Now we can calculate the total value by taking the number of groups, 2,952 divided by 8, and multiply that by the total value of each group, which is times 8. And the 8's just cancel out, so our final answer is 2,952. Question number 2. If 4 to the power of m is equals to 2 to the power of 21 times 2 to the power of 21 times 2 to the power of 18 plus 2 to the power of 20 times 2 to the power of 20 times 2 to the power of 20 plus 2 to the power of 22 times 2 to the power of 18 times 2 to the power of 20 plus 2 to the power of 16 times 2 to the power of 26 times 2 to the power of 18, what is the value of m? Pause the video here and give this question a good try. Firstly, we can use in this law of addition. This will simplify the problem into 2 to the power of 60 plus 2 to the power of 60 plus 2 to the power of 60 plus 2 to the power of 60. So we in total have 2 to the power of 60 in times 4. And 4 can be changed into 2 to the power of 2. And here we can apply the in this law of addition again to give us 2 to the power of 62. And that's just 4 to the power of 31. So our final answer is 31. Question number 3. We have a rectangular floor with dimensions 720 cm by 756 cm, and it is to be completely covered by identical square tiles. What is the greatest possible length in cm of these square tiles? Pause the video here and give this question a good try. Going to the crux of this problem, we're actually just trying to find the highest common factor of 720 and 756. Why is this so? Because this square tile, the dimension has to divide both 720 and 756. 1 is a number that clearly divides both numbers, but we want the greatest possible length, so it has to be the highest common factor. So let's find the highest common factor. We prime factorize 720, we prime factorize 756, and we look for the prime factors that they have in common. So they have 2 square and 3 square in common, so the answer will be 36. Alternatively, I can use a different method using something similar to the Euclidean algorithm. So I look at this rectangle that is 720 by 756, and I ask myself, what is the biggest square that I can fit here? And that's a 720 by 720 square. And what would be the leftover? Well, the leftover is 36 cm along the length, and I can fit a 36 by 36 square there. How many of such squares can I fit? Well, very nicely, I can fit 20 such 36 by 36 squares along the remaining gap. And that tells me that 36 divides 720 exactly, meaning that this giant square 720 by 720, I can also tile it with 36 by 36 squares, meaning that the largest possible length that works is actually 36. Question number 4. Given that a plus 8 over 5 is between 0 and 3 inclusive, and b minus 6 is between negative 13 and 0 inclusive, what is the smallest possible value of a times b? Pause the video here and give this question a good try. So first we can start by simplifying both inequalities. So the first inequality we can multiply by 5 throughout. That will give us a plus 8 is between 0 and 15 inclusive. Then we will subtract 8 throughout, and that will give us a is between negative 8 and 7 inclusive. For the second inequality, we'll just add 6 throughout, and b will be between negative 7 and 6. For the smallest possible value of a times b, either a is negative and b is positive, or vice versa. So let's take the case where a is very negative. So a is negative 8 and b is very positive, so times 6. That will give us a possibility of negative 48. Let's consider the other possibility. So we'll take a very negative value of b, which is negative 7, times a positive value of a, which is positive 7. That's negative 49. So the smallest possible value will be negative 49. And that's our final answer. Question number 5. What is the smallest positive integer n such that the sum below is a perfect square? So pause the video here and give this question a good try. Well, we can regroup this. What we actually have is 2023n plus the sum of the first 2023 natural numbers. And we can evaluate each of these parts. So the first part gives us 2023n. The second part is just 1 plus 2023 multiplied by 2023 divided by 2. This is your sum of AP formula. We can simplify this and factorize out a common factor of 2023, leaving us another factor, n plus 1012. So let's break this down. This needs to be a square number. So what do we know? We know that 2023 is 7 times 17 squared. So n plus 1012 needs to be 7 times some square number as well for the entire product to be a square as well. Well, we'll just guess and check. So let's guess some possible 7 times k squared. Well, 7 times 12 squared is too small. It's below 1012. And 7 times 13 squared, well, that works. That's just slightly bigger than 1012. So the purple factor, n plus 1012, needs to be 11,183, meaning that n would be 171. And that's our final answer. Which of the following has the largest value? Pause the video here and give this question a good try. So let's go by elimination. Let's look at option D. Option D is just 25 squared, which turns out to be the same as option A, is also 25 squared. And interestingly, option C is 24 times 26. Notice that A, C, and D are all clearly less than option E, so we can eliminate these three. 26 groups of 25 is definitely more than 25 groups of 25 or 26 groups of 24. So that's just simple math. Let's look at option B instead. So is option B bigger or option E bigger? Well, option B, we can simplify that by noticing that in our numerator we have a squared minus b squared situation. So we can factorize the numerator and cancel the common factor with the denominator, leaving us 25 squared plus 1. And if you look at option E, you can simplify that into 25 squared plus 25, and that's clearly bigger than 25 squared plus 1. So option E wins. And that's our final answer. Question 7. How many digits are there in the number 125 to the power of 125 times 8 to the power of 128? Pause the video here and give this question a good try. So this question, we have an easy way to work it out, because actually what we want to do is count the number of trailing zeros and see what's in front of that. And we can do that by breaking up the 8 to the power of 128 into 8 to the power of 125 times 8 to the power of 3. So this is our in this law of addition. So now we have a case of a to the power of n times b to the power of n. So we can combine the bases, and this gives us 125 times 8 to the power of 125. And 8 times 125 is a very important result that we need to know, because it gives us 1000 to the power of 125. And 1000 is just 10 to the power of 3. So this gives us 512 times 10 to the power of 3 times 125, which is 10 to the power of 375. So what this number is 512 followed by 375 zeros. So altogether, we're going to get 375 plus 3 digits. So our final answer is 378. Question 8, we're given a 5-digit number, so it's a concatenation of 6C9C0, and we are told that this number is divisible by 180, and we want to find the value of C. So pause this video here and give this question a good try. So firstly, 180 is clearly divisible by 10, and this concatenation, this 5-digit number, is also divisible by 10. So let's get rid of the zeros at the end. So for us to make this C work, we just need to check that the concatenation of 6C9C is divisible by 18. And 18 is the product of 2 and 9. So for 18 to divide this number, we just need to check that 2 divides this 4-digit number as well as 9 divides this 4-digit number. So for 2 to divide this 4-digit number, we just need to check the last digit. So that eliminates many options for us. So C must be an even number. So C is either 0, 2, 4, 6, or 8. Now, which one would work? Well, if 9 divides this 4-digit number, 6C9C, then 9 must divide the digital sum. So 9 must divide 6 plus C plus 9 plus C. And if we sum that together, this tells us that 9 must divide 15 plus 2C. So what possible C's would do that? Well, 0 doesn't work because 9 does not divide 15. Let's try C equals to 2. Nope, doesn't work either. 9 does not divide 19. Let's sub in 4. Nope, doesn't work. 9 does not divide 23. Let's try 8. Well, 16 plus 15 is 31. 9 does not divide 31. So we're only left with one value left, 6. But for the fun of it, let's check that as well. So 15 plus 12 is 27. 9 does divide 27. So 6 is our correct answer. Question 9, we are told that a squared is equals to 11a plus b, b squared is equals to 11b plus a, and we're also told that a is not equals to b, so what is the value of a squared plus b squared? Pause the video here and give this question a good try. So let's start by calling these two equations equation 1 and equation 2. We're going to start by subtracting equation 2 from equation 1. So on our left-hand side, we'll get our difference of square, a squared minus b squared. And on our right-hand side, we have 10a minus 10b, and we can factorize out the 10. So that gives us 10 times of a minus b. On the left-hand side, we can factorize the difference of square as a plus b times a minus b. Notice that we have a common factor of a minus b on both sides, which we can cancel away because a is not equal to b. Next, we can simplify this. A plus b will be equals to 10. Next, we can add equation 1 to equation 2. So on left hand side, we'll get a squared plus b squared, which is what we want to find. And on the right hand side, we have 12a plus 12b. Factorize out the 12, we'll get 12 times of a plus b. And since we know that a plus b is equals to 10, we can replace that and we'll get 120 as our final answer. Question 10. When the figure below is rotated 180 degrees, what is the resulting figure? Well, don't waste your time on this. You can just rotate the piece of paper around and match it. The answer is obviously this one. Question 11. Let k be an integer. Which of the following is always divisible by 5? Pause the video here and give this question a good try. So for this question, if you're not familiar with Fermat's little theorem, we can always do this by try and error to eliminate the options. So let's try k equals to 2 first. We substitute it in option B, that will give us 6. Well, that's not a multiple of 5, so we can eliminate option B. Let's try k equals to 2 in option C as well. You'll see that 32 minus 10 is 22. That's not a multiple of 5. We've eliminated another option. Let's try k equals to 3. In option A, you'll get 3 squared minus 5 equals to 4. That's not a multiple of 5, so we've eliminated A. So let's try to eliminate D. So we can substitute 1, 2, 3. Oops, they all seem to work. I've shown you the testing all the way to k equals to 9. You see that every option works. So we are very likely to choose option D here. Now, why is this true? We can use Fermat's little theorem. A to the power of a prime number is congruent to A mod P. What this means is that you take any number A and you raise, as long as A is co-prime to P, you raise it to the power of a prime number, it will give you back a remainder of A when divided by P. This means that k to the power of 5 is congruent to k mod 5, and k to the power of 5 minus k will give you 0 when divided by 5. So this is using simple number theory here. Question number 12. We can see that in this large circle, each quadrant of the large circle is made up of 2 identical semicircles of radius 7 cm and 1 large semicircle of radius 14 cm as shown. What is the area in cm square of the shaded region? Use pi to be the fraction 22 over 7. Pause the video here and give this question a good try. So notice that we can make some shifts. We can shift this small little circle and fill up this little gap, and same for the other 3 little semicircles. So what we'll get is actually 1 big circle minus away 2 medium white circles. So the big circle's area is equals to pi times r squared. R is 28, and subtract 2 times of the medium circle, which is pi times r, which is 14 squared. So if we calculate this, we'll get a final answer of 1232. Question 13. What is the largest integer m such that the fraction below is an integer? Pause the video here and give this question a good try. Alright, let's cover the broad strategy here. Since we want this to be an integer, 6 to the power m must perfectly divide 67 factorial plus 68 factorial plus 69 factorial. So to work out what is that integer m, we need to know how many factors of 2's and factors of 3's are there in the numerator, and whichever is the least, that would be our integer m. So let's simplify the numerator first. We can take out a common factor of 67 factorial. So that leaves behind 1 plus 68, which is just 69, plus 68 groups more of 69. So in total, there are 69 groups of 69. So we can simplify that as 69 squared. And 69 squared can be prime factorized as 3 squared times 23 squared. We've already found some factors of 3's in the numerator. So the rest of the factors of 2's and 3's will be hidden in 67 factorial. So let's work out the factors of 2's first. You can see that 67 factorial is going to have 33 even numbers in total. So you have times 2, times 4, times 6, all the way to times 66. So when we take 67 divided by 2, we are going to see that there are 33 even numbers. That's why you start with 33. And out of those 33 even numbers, 16 of them are multiples of 4, 8 of them are multiples of 8, 4 of them are multiples of 16, 2 of them are multiples of 32, and 1 of them is a multiple of 64. So each of these will contribute to one factor of 2. So in total, you're going to have 33 plus 16 plus 8 plus 4 plus 2 plus 1 factors of 2. You repeat the same process for 3's. Then let's use the index laws to add up all the factors together. You can see that in total we have 64 factors of 2 and 33 factors of 3. Hence, the largest that the integer m can be is 33. You'll see that if you have 34, you will have you can't divide any more 3's from the numerator. So the answer will be 33. Question 14. What is the sum of all the digits of the integers from 1 to 2023? So pause the video here and give this question a good try. For this question, we're going to break this up into two cases. The first case, we're going to consider the first 2000 digits from 0000 to 1999. And we're just going to include 0000 for convenience. So let's first add up the digits in the thousands place. Well, the first 1000 numbers do not even have 1000, so it's 1000 times 0. And the next 1000 numbers all start with 1, so that's 1000 times 1. So in total, the sum of the thousands place is just 1000. Now let's consider the sum of the hundreds place. So in the hundreds place, we have the numbers running from 0 to 9 repeated over and over again 200 times. So these are the 10 digits, 200 times. That's why you make up all 2000 numbers. Now, this means that the sum of all the digits in the hundreds place will be 200 times 1 plus 2 plus 3 all the way to plus 9. And this is just a simple arithmetic progression that adds up to 45. But we can just multiply this result by 3 because the sum of all the digits in the hundreds place is also equal to the sum of digits in the tens place and the ones place. So if we do this entire computation, we're going to get 27,000. So this 3 times 200 times 45. Next, let's consider the second case, which is all the remaining numbers from 2000 to 2023. And there are 24 numbers in total. Let's go column by column again. So let's look at the thousands place. Well, we have the number 2 repeated 24 times in the thousands place. In the hundreds place, we have nothing. They're all zeros in the hundreds place. Then we just have to add up the numbers in the tens place. So the first 10 numbers will be all zeros, then followed by 10 ones, followed by 4 twos. So the total will be just 10 plus 8. 18 is the sum in the tens place. And lastly, in the ones place, we have the numbers running from 1 to 9 twice and plus 1, 2, 3. So if we add it all up together, that's 162. So the total will be 28,162. Question 15. We are given 4 students A, B, C, D with last names Lim, Lee, Wong, and Goh, and they ranked 1st to 4th in the SASMO contest. Given that A and B are female, C and D are male, Lee said that she could have ranked higher if she studied more. D ranked higher than Goh but lower than B. Wong's teacher is proud of her results. A ranked lower than Lim, and C did not rank 3rd. We want the last name of B. Pause the video here and give this question a good try. Alright, from the pronouns, we can first tell that Lee must be female and so must be Wong. This already gives us a 50-50 guess that B is either Lee or Wong. This also tells us that Lim and Goh are both male. Since D ranked higher than Goh but lower than B, then D cannot be Goh. Therefore, D must be Lim and C must be Goh. So we can make a place order that student B is better than student D with last name Lim, who is greater than student C with last name Goh. Next, we know that A's rank is between Lim and Goh because A is ranked lower than Lim and Goh didn't get 3rd, so Goh has to be pushed down to 4th. Since Lee could have ranked higher, then B cannot be Lim, so B must be Wong. And that's our final answer. Question 16. How many different ordered pairs A, B can be formed from the list below such that A plus B is an odd number? So the list is all the numbers from 1 to 20. Pause the video here and give this question a good try. To produce an odd number, either A is odd or B is odd. because the only way to get an odd number is odd plus even or even plus odd. And bear in mind, this ordered pairs is symmetric. So if we just count all the odd, comma, even pairs, we can just times 2 to get the final answer. Now, to get the odd, comma, even pairs, now how many ways can we choose an odd number? We have 10 odd numbers, we want to choose 1, multiplied by 10 even numbers, we want to choose 1, and we times 2 because of the symmetry. So all in all, we have 200 such pairs. Question 17. The product of 3 different positive integers is 2023. What is the greatest possible sum of these 3 integers? Pause the video here and give this question a good try. So we can start by prime factorizing 2023, and this will give us 7 times 17 square. So you just have 3 different positive integers. But don't forget that one of the integers can also be 1. So we have now 4 possible numbers, and we need to turn it into 3 groups so that we add these 3 groups of integers together to give us the biggest possible sum. So common sense will tell you that we want to group 17 square together. So it will go like this, and the sum will be 1 plus 7 plus 17 square, and the largest possible result will be 297. Question 18. What is the greatest 4-digit multiple of 180 that has no odd digits? Pause the video here and give this question a good try. Since this 4-digit is a multiple of 180, then 180 must divide this 4-digit number. That means that 20 must divide this number, and so must the number 9. If this number is divisible by 20, this eliminates all the possible last 2 digits, and it reduces it down to either 00, 20, 40, 60, or 80. Then we can work our way downwards, starting from 9980, 9960, and check for divisibility by 9 by finding the digital sum. You'll see that all of them are eliminated except for 9900, where if you add up the numbers, 9 plus 9 is 18, and that's the largest number that is divisible by 9 and also divisible by 20. Hence 9900 is our answer. Question 19. What is the next term in the sequence below? 2, 3, 5, 11, 26, 57, 113, 205. Pause the video here and give this question a good try. When tackling these kind of sequence questions, it's good to just find the difference from one term to the next term. So let's just check it out. So it's plus 1, plus 2, plus 6, plus 15, and so on. Do you see a pattern yet? No? Then let's try this again. We'll find the difference of the difference. See, from plus 1 to plus 2 is just a plus 1. From plus 2 to plus 6 is a plus 4. Then a plus 9, a plus 16, a plus 25, and a plus 36. And by now you should see a pattern. You see that the purple gaps are all square numbers. Therefore, the next number has to be, the next difference has to be a plus 49, meaning it's going to be a plus 141, meaning that that next number in the sequence is 345. 205 plus 141. Question 20. How many factors of 7056 are not perfect squares? Pause the video here and give this question a good try. So we can tap on the principle of inclusion-exclusion to find the total number of factors and subtract it with the number of factors to find the number of factors that are not perfect squares. So let's first find the total number of factors first. We need to prime factorize 7056. We'll get 2 to the power 4 times 3 squared times 7 squared. Now, each factor of 7056 is a unique combination of the prime factors 2, 3, and 7. So for the factor 2, you can either have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, all the way to 2 to the power of 4. So 5 possibilities. Next, for the prime factor 3, either you have 3 to the power of 0, 3 to the power of 1, or 3 to the power of 2. So there are 3 possibilities there. And for the prime factor 7, again, you have 3 possibilities. So I'm basically taking the exponents of the prime factorization and adding 1 to each of them and multiplying them together. Next, for the perfect squares, we'll repeat the same process, except that now the exponents have to be an even number. This gives us 3 possibilities for 2. So the prime factor 2 either is 2 to the power of 0, 2 to the power of 2, or 2 to the power of 4. So 3 possibilities. For 3, the prime factor 3 can either be 3 to the power of 0 or 3 to the power of 2. So that's 2 possibilities, and same goes for 7 square. You're either no 7s or 7 square. So I subtract that, the final answer will be 33. Question 21. How many integer pairs satisfy the equation below? Mn equals to 5m plus 4n minus 12. Pause the video here and give this question a good try. So first, I'm going to bring everything over to the left-hand side. And I'm going to try to factorize it, and I fail. I can't factorize the left-hand side. But what I can do is if I add 8 to both sides, then my left-hand side is now factorizable under group factorization to m minus 4 times n minus 5. Meanwhile, my right-hand side 8 can be expressed as either 1 times 8, 2 times 4, 4 times 2, or 8 times 1. Since we know that m and n are integers, then m minus 4 and n minus 5 are both integers as well. So by grouping it this way, I can see that there are some possibilities for m and n. Either m minus 4 equals to 1 and n minus 5 equals to 8, or m minus 4 equals to 2, n minus 5 equals to 4, or so on. So working out for each pair, I get some possible values of m and n. So either m is 5, n is 13, or m is 6, n is 9. So each of these will give me one possible integer solution for this equation. So it looks like we have 4 possible integer pairs. But is that the final answer? Well, it turns out that integers can also be negative numbers. So don't forget that it could also be negative 1 times negative 8, negative 2 times negative 4, and so on. So we'll have 4 more integer pairs that satisfy this equation. So the final answer is 8. Question 22. How many 4-digit numbers have the digit 0 but not the digit 3 among its digits? Pause the video here and give this question a good try. Now let's say we have the collection of every 4-digit number. Firstly, we're going to use this set to represent all the numbers that have the digit 0, and this set is going to represent all the numbers that have the digit 3. So this question asks us to find this part, only the blue part. So to find that, we can split it up into 2 cases. Case A would be all the numbers that do not have the digit 3, and we're going to subtract case B, which is all the numbers that do not have the digits 3 and the digit 0. For case A, their first digit can either be the numbers 1, 2, 4, 5, 6, 7, 8, or 9. Bear in mind, it still cannot have the number 0 because we still want it to be a 4-digit number. But the remaining 3 digits can have the number 0. So in total, the number of such numbers would be 8 times 9 times 9 times 9, or 5,832 such numbers. In case B, we do not want both digits 3 and digit 0. The first digit will still be those 8 possibilities, and so will the remaining 3 digits. So they only can have the numbers 1, 2, 4, 5, 6, 7, 8, 9 in all 4 digits. And in total, there will be 4,096 such numbers. So our final answer will be 5832 take away 4096, which is 1,736. Question 23. In the diagram below, quadrilaterals ABCD and CEFG are a rectangle and a square respectively. It is given that the length of AB is 21, BC is 35, and the area of CED is 12. Find the area of triangle BCG. Pause the video here and give this question a good try. So first we let the length of the small square be A. Now notice that these 2 yellow angles are supplementary. They add up to 180 degrees. So if angle CBG is theta, then the angle of DCE is 180 degrees minus theta. Using the trig formula half AB sine C to find the area of triangles, we can find the area of this green triangle to be half times 21 times a times sine of 180 degrees minus theta. Using the obtuse angle formula, we can simplify sine 180 degrees minus theta as sine of theta. Next, we can find the area of this red triangle. That will be half times 35 times a sine theta. Notice that this would be 5/3 of the green triangle's area, and the green triangle's area is given to be 12, so the red triangle's area must be 20. Question 24. What is the smallest positive integer k that satisfies this inequality below? Pause the video here and give this question a good try. Firstly, if you look at the general form of this series, you can factorize the cubic denominator. This will give you k times k plus 1 times k plus 2. And you can further simplify this and split it into two partial fractions. Once you split each term into their partial fraction form, you can start cancelling the common terms. This will only leave behind the first term and the last term. So the first term, 1 over 2 times 2, that's 1/4. You can bring that over to the right hand side and you can remove the negative signs on both sides. This will simplify into 1 over 2 times k plus 1 times k plus 2 is smaller than 1 over 1000. This means that the denominator on the left hand side has to be bigger than 1000. So k plus 1 times k plus 2 must be bigger than 500. At this point, since we do not have a calculator, we will just trial and error some values of k. If I sub in k equals to 20, that's 462, that's still not 500. If I sub in 21, I'll get 506, which is just slightly bigger than 500, so 21 is our final answer. Question 25 is a cryptorhythm. All the different letters stand for different digits. We are told that a equals to 9. Find the value of s plus I plus m plus c plus c. So pause the video here and give this question a good try. Well, as you will guess, it's a lot of guess and check. I'm not going to go through the step-by-step for solving this as it is quite tedious. I'll just post my answer here. If you add up the values for SIMCC, you'll get 13, and that's the final answer. With that, we have come to the end of this walkthrough. If you have any competition papers that you might want a solution for, do send them to me and I'll add it to my to-do list. Thank you for your kind attention and have a great day of learning.